Hello everybody, this is the video for lesson 9.2, linear regression, and in this video I'm going to be going over problems D, E, and F. D asks us to use the scatter plot to write a slope-intercept equation for the linear regression line. The linear regression line is this red line right here. It's the line of best fit. And we can use the scatter plot because the scatter plot actually calculates the equation for this line for us, and it's right here. So slope-intercept equation, remember, is y equals mx plus b, where m is the slope and b is the y-intercept. So let's update the slope. Looking up here, it's 0.0683 times x. That's what that means. So I can say slope is 0.0683 times x plus b, the y-intercept. Let's go check again. Plus 402. So 402 is the y-intercept of that linear regression equation, just like that. Part E is asking us, what does the slope of the linear regression line tell us about the relationship between the two variables? Let's do a quick review about slope. And let's just look at these two examples that I have on the right here. If the slope of something is 3 over 2, remember, so that means slope is change in y over change in x. So a slope of 3 over 2 is telling us that the change in y is 3 for every 2 change in x. So I can say this means that as x increases by 2, y increases by 3. That's what that tells us. Or another way you can think of this as, you can also think of this as x increases by 1, y increases by 3 over 2. We can also determine that same thing from the slope. Now let's look at this example. If the slope of something is 0.8, well, that means the change in y is 0.8 and the change in x is 1. So I can say as x increases by 1, y is increasing by 0.8. That's what I can tell just from this slope here. So now let's bring that way of thinking here. So what is the slope of our linear regression line? Well, so we know that the slope is 0.0683. So I can say that as x increases by 1, the change in y increases by whatever the slope is, 0.0683. Now that's what I can say in general, but we actually want to be even more specific here, because instead of just saying x or just saying y, let's be specific to our situation. Well, what does x represent in our situation here? X-axis is the total cases of COVID-19. Right? Total cases is the x value. So now I can say as, instead of x, as the number of COVID-19 cases increases by 1, then whatever the y is increases by 0.683. Well, what is y? Let's be more specific. Y is total deaths from COVID-19. So I can say, instead of y, I can say total deaths from COVID-19 increases by that amount. Okay, so that's what I can tell from the slope of our linear regression line. And why do you think this type of correlation exists between the two variables, right? Why is it that as the number of cases increases by 1, the deaths also increases by this amount? That I'm going to leave for you to fill out. It's also something that you answered in lesson 9.1.